Alright, this is Taylor Christensen, and I am going to be presenting about the Grignard experiment that we did a few weeks ago. Okay, so we had 3-bromotoluene and methyl benzoate as our electrophile and nucleophile. So the first reaction we did was formation of the Grignard using 3-bromotoluene. And as you can see here, we have 3-bromotoluene with magnesium metal and diethyl ether to form the MgBr 3-bromotoluene Grignard reagent. And here is the mechanism with the radical formation of the Mg and then the Br attack to form the Grignard reagent. Now, in this reaction, there were multiple byproducts that could have been formed that we were trying to reduce. One of the first was the formation of the biaryl byproduct. So here is the Grignard reagent again, this reaction. And down here we have the formation of the biaryl compound where the radicals from what is now just the toluene from the 3-bromotoluene come together to form the biaryl compound. This could happen when the radicals here were in excess or if they were overheated. So some things that we did to try and reduce this happening was to keep the reflux at a lower temperature for a longer time to try and favor the formation of the Grignard over the radicals. We also were slowly adding the electrophile in the dropwise fashion after the Grignard was formed to again try and not excite the reaction and get the biaryl compound to form. Yes, alright. Then another byproduct that we were worried about was the formation of the aryl hydrogen product. So this is likely to occur when there is contamination of water in the reaction system. So again, you have the 3-bromotoluene reacting with the magnesium. Then you have this electrons from the bond here attacking water contaminants, grabbing that acidic hydrogen on the water, and then the Mg and Br come together and the reaction just sort of terminates. So some things that we were trying to do to reduce this was ensure that the glassware was free of water, which we started out with heated glassware from the oven to make sure that water had been evaporated from any of the glassware, and additionally making sure we weren't washing any new glassware or using pipettes that were wet or syringes that had been exposed to water, just to make sure no water was added to the system. And additionally, we had anhydrous solution that we were adding to the system to make sure there was no water. And then we had the N2 line going into the system to keep water out and making sure that no water was getting dissolved from the air into the system. This is one of the byproducts that, as we'll see later in the results, likely was formed, probably either due to some issues with our N2 gas line, or we might have had some water contaminants either in the syringes or the solution or maybe even the original glassware. So that was something that could have gone wrong and can be improved upon. And then the reaction we were hoping for with our experiment was 3-bromotoluene forming the Grignard reagent and methyl benzoate. And here we have the diethyl ether solvent and then our acidic workup. And here we'll go to the reaction or the mechanism. So we have the 3-bromotoluene and the methylbenzoate, and it attacks this double bond, C double bond O twice to form this 3-phenyl compound with an alcohol group coming off. So initially we have the Grignard attacking the ester, and finally kicking off the OCH3 group due to the formation or the favoring of the C double bond O driving force that will kick off that OCH3 group. And now we have a ketone with a benzene and a toluene on either side that the Grignard will come in and attack again. And then we only have carbon compounds coming off of that one carbon, so there's nothing to kick off, so it won't favor that oxygen double bonded to carbon again and reform. And so then we did an acidic workup, and there should have ended up with an alcohol group attached to these 3 phenyl groups, the 2 toluenes that reacted, and then the initial benzene ring attached to methylbenzoate. This was the reaction that we were hoping for. As we'll see, this likely did not occur, and this was probably due to issues at the very beginning with trying to get our Grignard to reflux. We likely did not either form the Grignard from the 3-bromotoluene, or we formed a very small yield of it. So that was likely the root of a lot of our issues throughout the rest of, as we were looking through the results, that was likely the root of a lot of the problems. So here is the IR spectra. As you can see, there's not too many interesting peaks. There's no alcohol group that we would expect in our over here, as you can see, in our final product that we were hoping for. Yeah, there was none of the alcohol group. All we see in the IR is peaks at about 1500 and 1600 that indicate an aromatic ring, which is good because all of our materials had an aromatic ring, so we were hoping to see that at least. And then we have a peak at 1722, which indicated an ester, which unfortunately was indicating that in this IR product what we had was likely methylbenzoate, our starting material. And like I said before, this is likely because of the initial issues forming that Grignard reagent, why we have this starting material in excess above anything else. So as we can see here, we had mainly unreacted methylbenzoate, and then if we look at the NMR, we can kind of confirm that same thought. So from the NMR, we have all of these peaks down here in the aromatic region that correspond to the methylbenzoate. As you can see, the peaks at A, B, and C correspond to what would occur in the resonance structure with the partial positives on A and B being more shifted to the left. So we have A, B, and C, so we have A, B, and C here, and similar down here. And we also have over at H this CH3 group ester that is indicated over here again in methylbenzoate, sort of confirming what we saw in the IR, with methylbenzoate being our sort of main unreacted product. Additionally, there were some more peaks in the aromatic region and also sort of around the peak that was picked as H, which indicated the aryl hydrogen byproduct. So we have the peaks E and F, which were, and J, which looked to be in this aromatic region that corresponds to the aryl byproduct. And then for that CH3 group on the toluene that formed over here, this peak I corresponds to, it is about 3.95, which is in like correspondence to what would be in a CH3 group coming off of toluene. We also had CdCl3 peaks, which is indicated at D, and then G looked like it was contaminant, or a peak that was contaminated from the grease of the IR. Also, we had a small peak at around 1.4, which looked to be water, which makes sense if we had the aryl hydrogen byproduct, that there should be some water contaminant. It also kind of confirms the suspicion that there was water contaminant, and makes sense that there is that byproduct, that aryl hydrogen byproduct. We also have the diethyl ether peaks right here, and then we have the TMS peak right over there. All right, so the percent yield, we had our limiting reagent was 3-bromotoluene. We have the calculations on the screen right here. Our actual weight for our product material was 0.921 grams of the product, which would have indicated an 80.1% yield, but since we didn't really see that product, that 3-phenyl group product, this is likely not an 81% yield of that product, but just 81% by weight of our starting materials and the aryl hydrogen byproduct. So as we can see, this was likely due, all these problems were likely due to the fact of the initial struggle trying to get the Grignard to reflux. We were doing all kinds of things to try and get it to start, but it just wouldn't reflux on its own. In the future, maybe we could have added more ether or more heat, or maybe tried iodine to try and get it to reflux, and maybe added more of it to the initial reaction. Also, we could do better at trying to make sure that we only added anhydrous solution to the product, to the reaction, and making sure that all of our glassware was clear from water to try and remove that aryl hydrogen byproduct. And that's it.